Howdy folks, Doc here with Last Best Tool, and let's talk about a few things today. First of all, let's talk about carbon fiber, let's talk about titanium, let's talk about this watch that people have been asking about for, well, since I started my channel, and of course the loss of that Titan Submarine, or that Titan Submersible. So I'm a big fan of carbon fiber and titanium. I love to see them both used like this. But that is a completely different world than a submersible that has to stand up to pressure. Carbon fiber has unique properties. I've been using carbon fiber, riding it in bikes since, I think, the late 80s. I was early on that bandwagon. I loved the idea, but early on, the carbon fiber was held together with traditional lugs and glue, and the glue, of course, hadn't been dialed in yet, so sometimes they came apart. They definitely fatigued. Carbon fiber has unusual properties compared to what we are used to with metal. And carbon fiber also has some really cool applications. The problem is, was it the appropriate material for that submarine? And it turns out the answer is yes and no. Yes, because it did actually work. I mean, I'm a DIYer at heart. That's what this whole channel's about. And I look at the design of that as kind of a DIY. The guy who created it was bragging about, using, say, an Xbox controller and off-the-shelf components. That's really cool, maybe for an RV, but for a deep sea submersible, that's not a very smart thing to do. Too many things to go wrong. Talking about Camping World as the source for the lights. If the lights happen to catch fire or something, you're in a confined space. They were probably made in China. They were inexpensive. They had, shortcuts in the wires and the circuit boards and, the cheap LEDs. I mean, that makes no sense. You're in a very small space that you can't do anything about. And we learned that way back with Apollo 1, that we have to have a way to get out of something, a confined space. And we also need to reduce our chance of fire. I was watching the way it was built. There's some videos that show up. The laying out of the carbon fiber, it looks like they're laying it in line, kind of like we wrap duct tape around things. That eliminates a lot of the strength of the carbon fiber. It works, for the directional hydrostatic pressure, but the carbon fiber is designed to work across a plane where the loads are shifted back and forth. And that's why it's so strong. It doesn't look at one single spot and then, apply all the pressure there. It kind of distributes it out over an area if it's designed right. But if you just lay it in one dimension, it's all the force is on that one dimension. And so if there's a flaw, and obviously you can see in the way they're mocking it up or building it up, there's no real containment for contaminants, for even hair by the people who are running the machines. And if that happens, you get hair in there, even a strand of hair, you've broken the integrity. And they're trying to make it, so it's as strong as possible, but also as light as possible. I mean, that is a huge risk. I've been in NASA clean rooms when spacecraft are being assembled, and there is no room for anything like that because it can be catastrophic in the future when that one point of failure, is exposed to a threat. And also, I was looking at the tools they were using, like when they were assembling it, and I'm thinking, is that a wobble socket? Why would they use a wobble socket on a situation, like on a door, or a globe or whatever they called the viewport or something? And it was crazy. The socket was just held off at an angle, and I thought, this is not where you want to use the inexpensive tools either. Yes, they might get you by, and fix a car or something. This is critical. This is a big deal. Every little thing. I mean, I was looking, where's the torque wrench? He looks like he's eyeballing this thing. Something I'd do. Anyway, let's take a closer look at a couple of things like this watch. People have been asking about it. What this is a Rolex Sea Dweller Deepsea. Now, the reason I'm bringing this up now is if you look, the actual depth rating on this thing is 12,800 feet or 3,900 meters, which just happens to be the depth that we're talking about with the Titanic. It weighs about half a pound. It's got a 5.5 millimeter thick sapphire crystal. It's a beefy watch, and it's my daily driver. And I've had other watches, other Rolexes, and I want something that I can wear and enjoy. You can see, yeah, it's all scratched up. You know, it's gone on all kinds of trips all over the place, stays on my wrist. It ought to be able to hang on to, you know, a drive across the country if it's designed for, you know, working at the depth of the Titanic. And in fact, it can go further. That's actually what it's rated at here, but in order to get the certification, it actually had to go or be stressed to at least 10% above that. So that puts it well over 13,000 feet. You know, you're measuring the depth in miles. Very thick watch. The way this thing works, and we're going to go back to that, the Submarine. This has two pieces, basically, two discs. The top disc here and this titanium disc on the base. And the titanium disc is actually inside this case frame, this circular piece that's screwed off. So there's a titanium disc and a sapphire crystal that's 5.5 millimeters thick. I mean, it's pretty hefty there. And those two are seated at each end of a stainless steel tube that is inside this. And that's what Rolex calls their ring lock system. So what happens is as the pressure increases, it squishes this little sandwich, this Oreo cookie together, and it tightens the area, the seal basically, between this crystal here and this titanium plate on the backside, and smashes that. And inside that is the movement. And the movement is also held down. There's a big crown here, you know, with shoulders to help protect it. But you actually screw that crown in, and then it's got 3 different seals, and it goes through 2 different, you know, the external case plus that stainless steel cylinder. So that's what's actually going on inside this thing. The other part, it says the helium escape valve. If you can see that original helium escape valve, what that is just this thing here. It's just a little tiny kind of a labyrinth that allows the helium molecules that could get inside this watch to get out. What happened in the past is if you're doing mixed gas diving, I'm not a mixed gas diver. I am a regular scuba diver, and I have been down underwater in, I guess what we'd call recreational submarines, but nothing dramatic, nothing to write home about. But anyway, what happens here is in a mixed gas environment, the tiny little molecules of helium can get inside the watch, and then as you come up and the pressure on the outside of the watch decreases, the pressure inside, because of those helium molecules that got in under pressure, is still there, and the crystals were basically blowing out of the top of the watches. So Rolex came up with this little design here. Basically, we're talking about there's hydrogen and then there's helium. So you're talking about the smallest, second smallest molecule there is, and that molecule can escape, but water can't escape. It's too big, H2O. Those are gigantic atoms connected to make that big molecule, and air, whatever that is, O2, CO2, something like that. You know, even nitrogen is huge, but helium needed a way out because it could get in between the cracks and the seals. Imagine that. It's that small, and it could be forced into those areas. But anyway, going back to the submarine, well, one of the things I want to show you is that the submarine was obviously lost by kind of a rapid decompression. Let me get this thing going here. Got a little prop here. There's fire. Oops, don't want to burn up my thermal camera. So I've got a can here. This is just an aluminum can, mountain water. And so I'm going to put that on here, and we're going to boil water inside it. Now what happens is when the water boils, this is actually going to fill up with water vapor. Water vapor, you know, there's a tiny bit of water in the bottom, and the water vapor is going to occupy all the space inside here, removing the air. So this will be full of water vapor. What I'm going to do is flip it over upside down into this water here, and it won't be able to get inside the can very fast. And when it does, it's going to allow the atmospheric pressure, 14.7 pounds per square inch, to really reflect the force. So what you see here, we've got some steam coming off the top. So what I'm going to do is grab this with some channel lock filter pliers. Make sure it's still steaming. Okay, here we go. You ready? 3, 2, 1. Okay, so that's what happened. Only on a scale thousands of times greater. The speed at which that happens and the complete effectiveness, was well below anybody's comprehension. So there was no suffering, no conscious awareness of what was happening, and even this was kind of inefficient. So it's a way of demonstrating, the force, atmospheric force. Every 33 feet down is another atmosphere. So you're talking, if you're 13,000 feet down, there's my calculator, basically you're dealing with thousands of pounds of pressure per square inch, which this is 14.7. Actually, I'm up high, so it's probably like, 13 pounds of pressure. But anyway, I also got this once. I was at a science conference. This is actual material that Alvin, the submersible, brought up from a deep sea area near the Marianas Trench. And this is actually fresh basalt. So this had just solidified. So for a while, this was like the youngest rock the human could touch on the planet. Unless you were in Hawaii and picked up a piece of lava. Same diff, except this is underwater. Anyway, so I've been watching this like the rest of the world. Really sad that it had that outcome, but not surprised. That was my very first thought, just like many others. I could not come up with another way that this would turn out that made reasonable sense, but I appreciated everybody going through the motions, trying to save what could be survivors. But in a situation like that, that's sad. But anyway, so there's the watch everyone's been asking about. Yes, it's real. I love this thing. I first saw it in Italy in 2012 when it first came out, and then wanted one. Didn't get around to it till like 2016. Finally picked one up, and I've been wearing it ever since. It's a great watch. And with that, Doc out.